Hey everyone, so today we're going to learn about some important built-in iterable methods in Python and how to use them. We're going to cover three very commonly used and important methods: sorted, map, and filter. We'll also then learn about Lambda functions and how they can be used with these methods to make things a little smoother. So simply speaking, in Python, an iterable is an object that can be iterated over or looped through. So some examples of iterable objects are, lists, tuples, strings, and dictionaries, and sets as well, but I don't have any of those here. So this is just some data we're going to be using with these methods in this video, and I just have them there for ease of use. So the first iterable method we're going to cover is sorted. This method really does what you think it would. It just sorts the data you give it. For its simplest use, all you do is just simply call the function by writing sorted. And this just creates an instance of the function, which then you need to pass it some iterable. And so let's just give it a list, which again is just this list up here, which I already had defined and just has some integers. But when we run it, we want to see the result, so we're just going to print the result. And now when we hit run, it sorts the data as we would expect. And the default is ascending order, and we'll learn why that is in a second. But really, we can call this on any of these. So, if I'm just going to print sorted of a tuple, and then I'm also going to print sorted of a string, and then the other one we'll also do a sorted of a string 3. I'm just going to call this one 4 actually, and make this 4. All right, so now when I run this, we can see that even though what we're giving these are different types, so we have a list and then a tuple and a string here, but the result of sorted is always going to be a list, and that's just always going to be what's returned by any of these methods: sorted, map, or filter. But you can pass it any kind of iterable object, but the iterable object you get back is always a list, and that's just how it works. But there's a few important things to note here. So when we're sorting these strings, it pretty much sorts as you would expect, except there's some important facts. So like the capital letters always come before lowercase letters, and then within that separation, they're each sorted. And then also, this one's pretty interesting. So we have this dash and a slash come before the numbers, but then the colon and a semicolon come before the letters. And this is what's the default sorted order of characters. And the reason for that is that this sorted method in Python, it defaults to sorting by something called like the ASCII character order. And so that's defined by this really old table, like dates back many years. And so this is just the character codes for characters we see anywhere. So there's a defined order, right? And so we have some of these non-alphanumeric characters here first, then the numeric characters, and then that's when now you see the colon and the semicolon here now, then the uppercase letters, then a few other different types of characters, and then lowercase. And that's why when we actually run this sorting, we see that it's uppercase before lowercase, it's certain characters before numbers, then other characters after numbers but before like letters. So that's just one thing to keep track of. I'll take the link to this table in the description of the video if you want to take a look and in a little more detail. So, anyways, there are another couple of interesting things you can do with sorted. So if you want to just tell it to be reversed, you can do so very easily. So I can sort a list, and I'll say reverse is equal to true. And so this is just an optional input. You don't need to give this because, as you see, we called it without that. You can give it and set it equal to true, even though the default is false in these cases. And now when I run this, we can see that it sorts in descending order. And the same would go for if I sorted even the string too. You see now it goes down. Then another important parameter that again is optional but can be very useful is, so if I want to sort a list, or why don't we sort this? We have this list of lists here, right? Number lists. So it's got or actually we'll call it strings. So we have a list of strings here, and we want it to sort it based on the length of the string. So we want the result to be that B would be first, then DD, then AAA and CC could be in either order. But we want the length to be the sorting. So now what we can say is we can say a key, and this key defines how you want it to be sorted, and you give it some sort of function. And so we can say length, remember, which is a built-in function to give us the length of something. And now when we run this, we get it sorted based on length, which is really, really helpful. Another thing we could do is with number lists, which again is just this other data here, a list of lists I have. Let's say we want to sort it based on the sum of the values in each list, right? So what we would want to be first is actually, is this one, right? Because this has the smallest sum, it's just 1. So we would want that to be the first value, and then the rest would come after. So we can just say is key is equal to sum, and now when we run that, sorry, typo here, we run that, we get it sorted in the order we'd expect. 1 is the smallest sum, this has a sum of 6, this is a sum of 45, and this is a sum of 102. Cool. So that's just really the sorted method. Again, it's just used to sort data, and it has some optional parameters such as reverse, and then also a really useful one called key, which is how you can define the specific way in which you want it to be sorted. So the next method we're going to do is called map. So map is similar to sorted, but it has a little more going on. So map also takes as input an iterable, like one of these data types, and what it does is you give it some other rule, some function that defines a rule that will then be applied to every element in the data. So that's a lot to say, but you'll understand what I mean in a second. So I'm just going to take these two functions here because they're going to be useful to us, and then I'm going to scroll down here, and so now we can use these functions as a rule. So if I want to map a list, and I want all the values in a list to now be negative. Well, I can do that very easily by just saying I'm going to map using negative, which again is this function right here. Neg is referring, because I defined it, as this function here, and I want to apply that to a list. So what's going to happen here is when I run this, map, this built-in function, is going to apply negative, this function, to every single element in a list. So what's going to happen is every element is then going to be inputted here as n, and then it's going to return negative n. So as you would expect, when I run this, now we just have the list of all the negative numbers, which is, again, we have this list, now it's all negative values. We can do the same thing with square. We can say map using square as the function rule, and then we're going to apply it again to a list. And when we run this, now we got the square of all the values. 9 squared is 81, 8 squared is 64, 1 squared is 1, 2 squared is 4, so on and so forth. So that is just a really cool method and can be used in a variety of ways, and just makes things really quick. Because we could write out a function that does all this. We could write a function that takes some data and squares it, or makes all the values negative. But it's really easy to just use map and do the exact same thing. We can also use some built-ins. So if I could say map of, let's say I want to make every integer in here, instead of making it negative, I want to make it a string. So I can say map with string being the rule function on a list. And if I run that, now you see every value is a string. Similarly, I could say I want to make each one a float, which again is just a decimal. Then that's what's going to happen here. So again, it's just really, really clean ways of modifying or mapping data to the way you want it. So let's move on now to the last method, which is filter. So filter is similar to map in terms of how it's called. It takes, again, as input, the first parameter or first input is going to be some function rule, and then the second input will be the data. So again, I'm just going to copy and paste some functions over here that we're going to use. The function, functions that will apply a rule. But in this case, the functions, instead of returning some value that you map it into, so here it makes it negative, here it squares it. What this returns, it's going to return some sort of truth value, some sort of Boolean. And if the Boolean is true, that means the specific element will be kept. If the Boolean returned is false, that means the element in that that iteration will be filtered out. Because again, this is a filter function. So let's do this with an easy example. So I'm going to say is even. This is the function rule, which remember is just this what returns is a Boolean saying whether or not it's even. Because n modulo 2 equals 0. This evaluates to true when n is even, and it evaluates to false when n is odd. So we want to filter out the odd numbers, and so we can do that with this is even. And I'm going to give it a list again, which is just this list of numbers here. And so what's going to happen is we're going to get only the even numbers back. That's what's going to be outputted. And, oh, sorry, I got to print it so we can see the result. And that's exactly what happens. So now we just have 8, 2, 4, 6, which are the only even values in here. Because when filter, again, like map, it goes through each element in the data you give it, in the iterable object you give it. So what happens is, filter goes through, okay, so it sees 9. It says, okay, I'm going to call is even on 9. 9 modulo 2 is not going to be equal to 0, so this is going to return false. So then the function says, okay, I'm getting rid of that number. Then it gets to 8, and it calls is even on that. It says 8 modulo 2, that does equal 0, so that's true, so 8 is kept, and that's why we can see 8 here. And then it goes through that for the rest of them. It does the same thing on 1. 1 is not true, so it's not kept. 2 is true, it's kept. 6 is true, it's kept, and so on. So let's just try some these other functions we have here. So let's filter out. We want to filter out the negative numbers. So I'm going to say that means we want to keep the positive numbers. So if it is positive, we want it to return true. But now we need a list of negative numbers. But again, we can just define that by saying, okay, I'm going to make negnum numbers equal to mapping of neg, which again is this function here. And then, as we saw before, right here, when we printed this, it turned all the numbers to negative. So now, with the negative numbers is going to be a list of the negative values in here. And all we have to do is just with this one line, we just mapped a list into it. So now, when we call filter out on negative numbers, we should get an empty list. And that's exactly what we do get. And so here's what happens. So we took a list, which is this list of all these integers. We mapped it into a list of the negative values. So it took every single one of these and made it negative. And then we set that equal to negative numbers. And if you don't believe me, I'll print negative numbers here. And so when I run this again, we see that now negative numbers are all these negative numbers. Now we called filter on negative numbers with the function rule being is positive. So this will return true only when n, the element, is greater than 0. Since none of these values are greater than 0, they're all negative, what this will return is going to be an empty list because there's no values to keep. It filtered every single thing out, right? Because that's what filter does. It just, if it's false, it filters it out. So that's pretty cool. We can also, again, call these on strings. So if I want to take, let's say I have this string here, whatever, some random string, and I only want to keep A or B, right? Or if imagine if there are a bunch of other A's and B's, they don't have to be next to each other, right here. And so what I want to do is I want to get rid of all the mess and only keep the A's and the B's. So what I can say is, okay, is A or B, because again, this is a function I defined and wrote, so it returns true if x is equal to A or x is equal to B. And so now I'm going to give it the string is, what was it called? It was a string 3. So when I print this now, we get exactly what? It's only the A's and the B's. So this was this huge long string over here with all this mess in it, but what we get out after calling filter on it is just the A's and the B's. So here's that first AB right there. We see another AB here, so we get this AB here. We see an A here, another A, B, and B over here. So that's what gets this. All right, cool. So those are all the methods we're going to go over. So we saw sorted, which again just sorts the data. You can give it a key, which is kind of similar to these functions you give over here. And then you can also say whether you want it to be reverse. Then we have map, which again you give it some data as the second input, and the first input is like a rule or a function that is applied to every single element in the data, and then it returns that result, and because it maps the data into that new value. Then we have filter, which is similar to map, except instead of changing the data, it just gets rid of some of the data according to whatever rule you define. All right, so those are all the methods. Now we're going to go over what we were saying, which is lambda functions. So these are very useful in conjunction with iterable methods. These methods we've seen: filter, map, sorted. There are some other ones, but these are like the most used ones. Lambda functions are a really helpful tool when using these methods. And that's because these lambda functions are really just anonymous functions, meaning they're functions that go unnamed and are not really defined in a classical way. When we define functions normally, what I mean by classical ways, we use this keyword def, we name it, we define the inputs here, and we have this colon, and then we do all this body. So that's like a full, all the syntax to define a function. Lambda functions are really cool because they're anonymous. We don't need to do all that. It's for when we have like very simple one single expression functions, and we want to just pass them as input to other functions. So let me show you what that would be. So what I say is I can say lambda. That's the keyword saying it's a lambda function. And I'm just going to call the input x. Again, you can call this anything you want. X is just sort of a classic way of calling it. And what I'm going to say is now I want x to be squared. Okay? So now if I want to print map, what I can do, instead of having to, you see how over here we use this define square function, and then we called it in here, right? We used square, and we applied it to a list, and we saw that in action. We saw the result be what we expected. But now, I'm just going to comment these out really quickly. Now what we're going to do is, instead of doing that, we're going to take this lambda function, we're just going to throw it directly into here. Okay, and now we're going to still call it on a list. And what's going to happen is this lambda function is just the function that's going to be applied to each element in the list. It's going to say, it's going to refer to each element as x, and it's just going to change it to x squared in a really kind of clean, easy way. So now when we run this, it does exactly what we want. Now I'm going to show that that's the same as what we did here, right? So I take this here. So here is when we took this defined function called square. Remember, I defined it up here, and we applied it to a list. But again, we had to define it out here and then do it this way. These are going to return the same thing. See, they're exactly the same. But this lambda function is just a cleaner way of doing it, because this is a really simple function. All it's doing is just taking some input and returning it times itself, or squaring it. There's no need to really define a full function to this, because what you can do is just use this lambda function, make it, again, it's an anonymous function. It just says, you define using lambda, and then it has no name. Nowhere did I give this a name of a function. All it does is it takes x and squares it. And that's really, really useful. We can do the same thing with is_even. So I had, before, I was filtering out the evens, right? Over here. I'm going to comment this out again. So that was taking this function is_even, which returns whether or not an element is even, and it was applying to a list. And again, that worked. We only got the evens back. But again, this is a really simple function. We don't really need to define that in such a set out way. What I can do instead is I can say filter and give it a lambda function. And so it's going to take, again, we'll just call it x. And then we're going to say x modulo 2 is equal to 0. So again, that's the same thing we had here. That's the logic of determining whether a number is even. Because if modulo 2, just wraps around, if it is equal to 0, it means there's no remainder. It means it's an even number. If there is a remainder, if it is 1, then it's not even. And so now we just give this a list again, and these are going to return the exact same thing. And they do. Because again, this lambda function encapsulates all the logic of this really defined out is_even function. It just doesn't have a name. It doesn't have any of this syntax really. You just say lambda, and Python recognizes, okay, this is an anonymous function, and this is what it does. It's just a single expression, evaluation. Cool. So that's all we're going to cover today. We went over 3 methods: sorted, map, and filter. Sorted just sorts data like this. Map, takes data and maps it into a new value according to some rule. Filter takes data and filters out values according to some rule defined by these functions. And then with all of these, you can just use, instead of the defined functions like these, you can just use lambdas and make it a lot smoother, a lot simpler, and a lot cleaner. And it can just, you don't have to get bogged down in all, this definitions and all that stuff. Cool. So Thanks for watching, and please add any questions or comments you have below, and I'll see you next time.